Hello friends, in this video we are going to see how to use a linked list as a queue. First, let us talk about the queue. The queue operates on FIFO principle. This means first in, first out principle. In the railway ticket counter, the person who gets the ticket removed from the queue front. So once the person in the ticket counter issues the ticket, the person gets away from the queue. That means a person will be removed from the front of the queue. When a new person arrives he or she will be land at the tail end of the queue. So that's how the queue operates in railway ticket counter. The same way the queue here in Java works. So when a new element is added, it is added at the tail end, and when an element is removed, it is removed from the head of the queue. The queue methods. Here we are going to operate our linked list as a queue. So this is our linked list structure. The linked list at present has three elements, E1, E2 and E3. E1 is the head element and E3 is the tail element. We know that linked list implements a list interface. It also implements dequeue interface, or some people call it as a deck. The deck interface is derived from queue interface. So this is how we can operate an linked list as queue. That means we use the queue interface and call its method. So when we call its method, the linked list will act as a queue. So let's say we have the queue interface and we are making call to add method. So what happens, the add method will add an element at the end of the linked list. That means at the tail end of the linked list. Here the tail end is E3. So when we add an element, it is added to the tail end. That means E4 is added after E3. When we remove an element, it will be removed from the head of the interface. Here the head is E1. So when we call the remove method, the element E1 will get removed from the linked list. And the new head element now is E2. So the index also renumbered. Now when we make a call to element method of the queue interface, it removes the element, it won't remove actually, it retrieves the element from the head. Here the head element is E2, so the E2 element is what returned to the caller. If you see, the element retrieved is E2, but it is not removed from the queue. The remove method will remove the element from the queue, but element method won't remove it, but it will give the head element to the caller. So you can inspect with the retrieved element and you can check its member or make a call to some of its member function. All the stuff you can do. Alright, now let us look at the queue interface and how we can use that with linked list. So here we are using the same product class which we previously used in the demo for array list as well as linked list. Previously we used array list and linked list as list by making use of the list related function. So here we are going to use the same product. Here is the quick glance of what is that product. It has two members, product ID and product name. Then we have a constructor. Then we have getter and setter methods. And there is one toString method. Finally, we overrode the hash code and equals method. So this we already did in our previous example. So here is a quick glance so that you know what is get added here. So here in code snippet 1, if you see the right hand side, we are actually creating the same linked list. Previously we created a linked list. In the left hand side we used the list interface, but this time we are using the queue interface. So we are creating queue products equal to new linked list of product. So the product in the angle bracket specify that it's a strongly typed interface. That means here, since the linked list is a strongly typed and you can add only product to the linked list, the queue is also declared the same way. So the queue of products equal to new linked list of product. After that we create 6 products, pencil through sharpener. Then we are adding it to the queue. Here if you see, the products type is queue interface. That means you are making call to the add method through queue interface. So now our linked list acts as a queue. So now we make a call to add method. What happens, each add method will add the product towards the tail end. Then we have print products at line number 25. The print product method is changed to accept queue interface as an argument. After that, nothing got changed from your previous example. So we just print product details. After that, we iterate through the product using the for each construct. Then we are printing the product. That's how this print products does. So add method wise, if we see, there is no difference between linked list used as list as well as queue. So when you use linked list as list, it adds the element towards the tail end if it doesn't specify any index. If you see in list interface, you can actually add element by specifying the index also. But if you add an element without specifying any index, it will be added towards the tail end. Same way in queue also, the product is added at the tail end. I mean the element is added at the tail end. But when you call remove, in queue interface, the remove method will actually remove the head element. But in linked list, the remove will remove the tail element, but in queue, the element in the head will get removed. So that's the difference. So here we are calling the remove method 3 times. That means 3 head element get removed. After that we are adding the product once again. We are calling the add method 3 times. So here we are making sure that the removed elements will re-added to the queue towards the tail end. So when we debug it, you can see it clearly. So after that, what we are doing, we are retrieving the 2 products. First we are calling products.element. It will return product 1. Then once again we are calling products.element. It will return product 2. We will print both product 1 and product 2 and see what happens. So absolutely we'll see that same element get retrieved 2 times, because the element method will not remove the element from the queue, it just gives the element to you. That's all here. Let us put a breakpoint and experiment this. So I'm going to debug mode. So we just created the queue. Then we are creating 6 products. After that we are adding the product, and you can see how the products get added to the queue at the tail end. Have a look at here. First pen is added, then pencil, rubber, writing pad, clips, sharpener. So now when we print, it will print whatever you see here. Now let us remove the product. Here we are calling the remove 3 times consecutively. Now if you see, the element will get removed from the front. That means you can imagine that here is the ticket counter and each element get removed one by one. Now pen will get removed, then pencil, then rubber. Now when we re-add all those 3 elements, it will get added towards the tail end. Pen, pencil and rubber. Now let us just make a call to element method. So it will give writing pad in product 1. In product 2 also we will get same. So here we are printing product 1 and product 2. So let me give more room, and you can see here what get printed in the console output window. So it prints writing pad, and here also you can see that writing pad is not removed when we make a call to element. So we already made call to element and the writing pad is still in the list. So that's all in this video. Thanks for watching. Bye for now.